Welcome to my YouTube channel. So today I'll discuss non-existence of limit. Till previous lecture I have discussed only the existence of limit by delta epsilon definition. Now today I will discuss non-existence of limit. So first of all, two-path test of non-existence. If from two different paths through which points x comma y approaches to x0 y0, the function f of xy has different limits, then we say limit x comma y tends to x0 comma y0, f of xy does not exist. So if we find this limit as xy tends to x0 y0 of this function, so as this x y, and if this x0 y0, and we choose zoom version of this x0 y0 neighborhood, so x comma y approaches to x0 through different paths, infinite number of paths. So most general path is first this is y tends to y0, and then x tends to x0, and from there first by this straight line, that is x tends to x0, and then it can come through this y axis, that is y tends to y0. So there is infinite number of paths through which x comma y approaches to x0 y0. So if we can find that for two different paths through which this point approaches to these points, and we can find the value of this limit which comes out different, then we say this limit does not exist. And another thing is path independence. If this limit x comma y tends to x0 y0, f of xy equal to L exist and unique, then for any path through which this x comma y approaches to x0 y0, the value of this limit will be same and equal to this L. So if this limit, that is called double limit, as this double point goes as x tends to x0 and y tends to y0 simultaneously, then this is called double limit. Whenever this limit exists, then for any path the value of the limit will be same and it's equal to this double limit, value of this double. So whenever this limit exists, then it will be path independent. And when path dependent, if we choose two different paths and we find the value of this limit through each of these two paths, then if the value of this limit for these two different paths be zero, be different, then we call that limit is path dependent. Now we discuss some example to clear this path independent and path dependent case. So first of all, take limit x comma y tends to 0 0 function x into y divided by x square plus y square. So first, if we choose this is 0 0 point, and if we choose a deleted neighborhood of 0 0, this is a zoom version, and it will be any point xy, then it approaches to 0 0 through many lines. First we choose along y axis. that is x equal to 0. Then this limit, if we put x equal to 0 here, the xy becomes 0, that is numerator of this function be 0, and then this limit becomes 0. And if we find this limit along x-axis, that is y equal to 0, and if we put y equal to 0 here, we get also the value of this function is 0. So for two different paths we get the value of this limit same, but from this we cannot conclude that the double limit of this function exists, because there may be another path other than these two paths, x equal to 0 and y equal to 0, for which value of this limit becomes not equal to 0, that is different, and then we call it limit of this function does not exist. So let us choose path y equal to x. So we choose this path y equal to x, and before these two case we choose one is this and one is this. So when we choose y equal to x, then this limit becomes as y equal to x, then x comma y tends to 0 becomes x tends to 0, and x y equal to x, so we put x, and this becomes x square plus y square means x square. If we put this, and from this we get limit x tends to 0, x square divided by 2x square, x square cancel out, and then get 1 by 2. So we get two path. One is y equal to x and another path x equal to 0 or y equal to 0, for which the limit of this function are different. One is 0 and half. So from this we can conclude that this limit is path dependent. So limit does not exist. So this limit does not exist. You can note. Also you can see path dependency for this function xy tends to 0 0, xy divided by x square plus y square. So simply let us take path y equal to mx, where m is any real number. So basically we choose the path through which xy approaches to 0 0. So it is y equal to x, all this path. When we take m for different value, we get this line, this straight line. When we take m belongs to r, then y equal to mx be these lines for different m, different line. So for this, when we put this y equal to mx here, we get limit x tends to 0, and this becomes x into mx, and this becomes x square plus m square x. This becomes limit x tends to 0. This is mx square divided by x square into 1 plus m square. M cancel out, so this becomes m by 1 plus m square. So this is dependent on m. So if we choose y equal to mx, m belongs to r, so we get the value m by 1 plus m square, which is a function of m, so depend on m. So for different m we get different value for this limit. From this we can conclude this limit does not exist. So we have shown this by path dependency. So this limit is path dependent. You can note down. Now we take another example. Let us take limit xy tends to 0 0, x cube y divided by x to the power 6 plus y square. So if we choose x-axis or y equal to 0, we simply get the limit of this limit 0, and if we choose y equal to x cube, then we get limit x tends to 0. From this we get limit x tends to 0, x cube into x cube divided by x to the power 6 plus y square, that is x to the power cube whole square, that is 6. So from this we get x to the power 6 by 2x to the power 6, that is limit x tends to 0, this becomes half. So for two different paths we get different values for this limit. Therefore we can conclude this does not exist. This limit does not exist. How we choose y equal to x cube? So let's see from here. This is x to the power 6 and this is x to the power 3 and y to the power 1. So if you choose x to the power 3, x to the y equal to x to the power 3, then we get x to the power 6, 3 plus 3 6, and from here also x to the power 3 to the power 2 equal to x to the power 6, and that's why we take here y equal to x to the power 3. So now we take another function, that is function of three variables. Let us take limit x y z tends to 0 0 0, and let us take the function x y z divided by x square plus y to the power 4 plus z to the power 4. So the highest power x to the power highest power is 4. So if we choose x equal to k into t square, so this becomes t square, and y equal to t and z equal to t. T is a variable or parameter. So this is a path in 3D. So then from this limit we get, if t tends to 0, then this x comma y comma z becomes 0 0. So this becomes limit t tends to 0, and x this kt square into y this is t and z this is t divided by x square, that is k square into t square, plus y to the power 4, that is t to the power 4, this becomes 4 plus t to the power 4. So from this we get limit t tends to 0, this becomes k into t to the power 4 and t to the power 4 common, and then we get k square plus 2. So this becomes k divided by k square plus 2. So this depend on k. So if we choose this path and we get the value of this limit depend on the parameter depend on k. So this is path dependent. So we can conclude from here this limit does not exist. So for today that's all. So I will discuss double limit and repeated limit and the relation, some properties and some example in the next lecture. So if you like it, do subscribe and please share with your friends. Thank you very much.